Okay, in this video, we're going to be learning about graphs and zeros of polynomials. So make sure you get your heading on your paper. For this one, what we're going to be doing is looking at the graph and seeing where the zeros are, because that's important. And I'm going to give you an equation, and you're going to be able to find the zeros based on that without a graph. So the first thing we want to do is come up with the definition of a polynomial function. So can you write it is, hopefully you have all this down, and please pause the video if you need to. It's a function consisting of terms that have whole number powers only. And what I mean by that is their exponents are only whole numbers, like 1, 2, 3, 4. Could be 0, but that's just a regular constant. So no fractional exponents. So we're going to, again, look at some graphs, and I'm just doing samples of it, sketches, so they don't have to be perfect. So what we're going to do for this first example, can you write example A? Sketch the graph. And circle the x-intercepts. So sketch the graph and circle the x-intercepts. X-intercepts are also, just so you know, called roots, so can you put roots at the end? So we're going to do 3 examples. So 1, 2, and 3, just so you can get a quick idea. And I'm just going to make a really quick sketch, or really quick x and y axis for each one of these. And again, it doesn't have to be perfect. So x and y axis for all of these. Okay, so if you need more time, feel free to add that on. All right, so we're not finding the exact values here. We just want to know approximately where they touch the x-axis. So for number 1, can you write y equals x cubed minus 3x squared minus 6x plus 8. I'm just going to type that in my calculator just so you get an idea of what it looks like. We're not going to do exact. I believe that we did this on the other notes. So if I hit my graph, I'm going to adjust this a little bit. Hold on a second. I'm going to make my graph. I'm going to change this to negative 20 to 20. Oops, sorry. Let's change that. I want to make sure. Negative 20. Okay. So I'm going to have my graph look like this, so we can see pretty much everything clear. So I'm going to have us sketch that. So it looks like it touches the x-axis at -2, and then at 1, and then at 4. So I'm just going to make a quick sketch, having it go through. Look something like this. All I care about are the zeros. And I'm just going to circle those. I don't care about the specific numbers right now. I'm just trying to get an idea of what it looks like. So powers of 3 will look like this. Let's do another one. Y equals 2x cubed minus 8x plus 9. And while you're writing that, I'll go ahead and type that in. Notice this touched 3 times when I type this one in. And I hit graph. Notice it only touches it once. It kind of hovers right above. So I'm going to show that it probably touches around here. Go up a little bit, go back down, and then go back up. Notice that it only touched the x-axis once. So there's only one root, one x-intercept. And the last one we're going to do is y equals, I'll cover this, 2x cubed minus 12x squared plus 18x. I'll go ahead and do that in my calculator so you can take a look, and you can always practice these on your own. Make sure you can type these in and see what they look like. So if I hit graph, notice on this one, it goes up, hits the x-axis, it goes right back up. Oh, here we go. So we're going to make it look something like that. So I'm going to take my about here and about here. So I'm going to bring it up. And as soon as it hits the x-axis, I bounce it back up again. So here we have two x-intercepts. So the thing I wanted you to notice is when we have a power of 3 function, you could have up to 3 zeros. When we have a power of 4 function, I want to show you, I will make up an example here. If I go to y equals, and I'll put in x to the 4, just want to show you what one would look like. Minus 5x squared plus 4. When we have a quartic function, we could have up to 4 zeros, 1, 2, 3, 4, touching it 4 times. So can you write for me underneath this? A cubic can have 3 x-intercepts. Underneath that, can you write a quartic, that's a power of 4, can have 4 x-intercepts. So what we're going to do right now is I'm going to give you an equation algebraically, and you're going to come up with our zeros, our x-intercepts, our roots. I just want to point out one last thing before we get into our steps. Can you write for me x-intercepts? X-intercepts can be called. So x-intercepts, you could hear it as x-intercepts, you could hear it as roots. You could hear it as zeros. It's also going to be our solution. So can you write solution? So when you hear the question, what are the x-intercepts? It means the same as if you heard them say, what are the roots? What are the zeros? What's the solution? So I'm going to show you right now how to find the zeros if I give you an equation, which ties into our factoring. So can you write steps to finding x-intercepts algebraically? So these are our steps, and we have 3 of them. I'm making them short and sweet. So if we were trying to find the x-intercepts algebraically, number 1, you're going to set it equal to 0. So can you write set it equal to 0? So you're going to take whatever the equation is, you have y equals, you're going to change that y to a 0. Step 2, you're going to factor it. Step 2, you're going to factor. And then step 3, you're going to solve. So we're going to do 3 examples to practice that, and I have graph paper because we're going to try to be a little accurate when we graph our solutions. So I'm going to switch to the second page, or the back, and this is going to be example B, and we've got 3 parts here. So can you write for example B, here's the directions. Determine the zeros. Determine the zeros and sketch a graph. So those are the directions for all 3 questions. So here's number 1. We're going to do 3 of them again. So can you write y equals x cubed minus x squared minus 12x. So we're going to find the zeros, and I'm going to check in my calculator after. So the first thing to do, step 1, is to make this equal to 0. So we're going to take x cubed minus x squared minus 12x and set it equal to 0. We've done this before in our quadratic chapter. Second step is to factor. So the first thing I notice, there's a GCF of x. I can take an x out of everything. So when x comes out, big set of parentheses. So if I take an x out of every term, I'm left with x squared minus x minus 12. Don't forget equals 0. Now I bring down the x. I can't get rid of it because that's a letter. And I'm going to make my 2 sets of parentheses. Again, don't forget equals 0. Now I'm factoring. So x and x in the front. factors of 12 that subtract to give me 1. So I'm going to go to y equals and do 12 divided by x. Go to my table. Make sure I start with 1. Factors of 12 that subtract to give me 1 would be 4 and 3. I want a negative 1, so that means 3 minus 4. So 3 is positive, 4 is negative. Now I solve it. Step 3 is to solve. So I don't get rid of this. This is part of my answer. So I'm going to write x equals 0 because we have 3 things being multiplied equal to 0. The next one is x minus 4 equals 0. And then your third equation is x plus 3 equals 0. So we're going to have 3 answers here. So our first answer is done for us. Our second answer, we're going to add 4 to both sides. 4's cancel, so we have x equals 4. In our third answer, we're going to subtract 3 from both sides. We have x equals negative 3. Now, on the right-hand side, we're going to make a graph of this. So I'm going to draw my x and y axis. You don't have to use a ruler. It'll look nice if you do, though. You can just use the edge of a folder, notebook. So we have our x and y. These are our zeros. So, can you write 0 and plot a point? Can you find 4 on the x-axis and put a point? 1, 2, 3, 4. And I'm going to put 4 there. And then find negative 3 and put a point. 1, 2, 3. Our graph is going to go through these points. Any power of 3 has a shape that starts on the bottom and goes up. So I'm going to use my calculator here just to be accurate, but you should be able to figure out the pattern without it from now on. I'm going to type in my equation just to get a look at it. And I'm going to change my window really quick back, just so it's a regular graph. All right, so if I hit graph, that's kind of what it looks like, but I want to make sure I can go really high. I'm just making a sketch. So I'm going to start from the bottom, go up, goes back down, and then back up. I don't really care about in terms of how high or how low you go because we're not really looking at minimums and maximums. What I'm concerned about are the zeros, okay? To see if those zeros are right, we can go to y equals, we typed it in already. I'm going to go to my table and see if these 3 numbers have 0 after it. So I have 0 with a 0, I have 4 with a 0, and I have negative 3 with a 0. So those are our zeros. So any power of 3 is going to start from the bottom and go up. Here's example 2. Can you write y equals x to the 4th minus 5x squared plus 4? So to find our zeros, we are going to take this equation and set it equal to 0. So x to the 4th minus 5x squared plus 4 equals 0. All right, there is no GCF, but I want you to think of the problem like this. I'm going to take away that power of 4. This will be the same as x and x. Factors of 4 that add up to 5 would be 4 and 1. And I'm adding, so they need to be the same sign, so both negatives. The difference between this one and this one is the power of 4. So instead of just having x and x, we're going to have x squared and x squared here. So 2 sets of parentheses, don't forget equals 0. Instead of x, it's going to be x squared and x squared in the front. Still, I'm going to have the 4 and 1 in the back because factors of 4 that add up to 5 would be 4 and 1. And our signs are negative because we're adding and there's a minus. We are not done because there's still a power of 2. If you look, perfect squares with a minus. So look what I'm going to do with the first one. 2 sets of parentheses. X times x gives me x squared, so x is going in the front. 2 times 2 gives me 4, so 2's are going to go in the back. And because there's no middle term, I have opposite signs. I can do the same thing over here. 2 sets of parentheses because they're perfect squares. I don't want to forget equals 0. X times x gives me x squared, so x is in the front. 1 times itself gives me 1, so 1's in the back. And then opposite signs. I do not have any more powers of 2, so I can go ahead and separate. So I'm going to have 4 equations. X plus 2 equals 0. X minus 2 equals 0. X plus 1 equals 0. and x minus 1 equals 0. And now I just solve them all. So I can go through this kind of quick. First answer is -2. Second answer I add 2 to get x equals 2. Third answer I subtract 1. I get x equals -1. And fourth answer I add 1, so x equals 1. Those are my zeros. So now I can take my ruler, make a little graph out of this. My zeros are what I care about, so I'm going to put points at these 4 numbers. So at -2, at +2, at -1, and at +1. Because it's a power of 4, it's going to be a W shape. So I'm going to kind of take a look just to make sure I'm on the right track. So I'm going to type in x to the 4th minus 5x squared plus 4. I hit graph. That's what my shape should look like. So I'm going to go ahead and W. It'll always look like the W if it's power of 4. So I'm just making it. There's my graph, and I can check to see if I'm right. If I go to my table, I need to see that next to every one of these numbers, there are zeros, and if you look, they are -2, -1, 1, and 2 have zeros next to it. The last one I wanted to talk about is if we have a negative in the front. Notice when you have a power of 3, it always comes from the bottom. When you have a power of 4, it always comes from the top, making a W shape. When you have a negative in front of the equation, it's going to flip the graph. So here's example 3. You write y equals -x cubed plus x squared plus 12x. I'm going to have you circle something and write, just so you know, when you have a negative in the front, you're going to factor out the negative. So factor out the negative. Then you're going to see what happens to the graph. So first thing we do is set it equal to 0. So we're going to have -x cubed plus x squared plus 12x equals 0. You want to take out the negative if it's in front. So what we're going to do is take out a negative, big set of parentheses. I'm kind of doing this in 2 steps so you can see it. If I'm taking out a negative, every term changes sign. So -x cubed becomes x cubed. Plus x squared becomes -x squared, and plus 12x becomes -12x. Now I'm going to pretend that it's this and do what I've done above. So if you notice, it's exactly like the one above. This is number 1, except for there's no negative in the front. So I'll just keep carrying on. We're going to take out the GCF, that's an x, so I'm going to take out an x with that negative. In parentheses, I'm going to put what's left. So we have x squared. Take out an x here, minus x. Take out an x here, minus 12. I still can factor this because it's a power of 2, so you take out the x, 2 sets of parentheses. And again, we did this above. I'm just showing you what happens with the negative. So I take out x and x. Factors of 12 that subtract to give me 1 are 4 and 3 again. We're going to do 3 minus 4 to get -x, so 3 is positive, 4 is negative. And now I split them apart. So I have 3 answers because x counts. So I have -x equals 0. We have x minus 4 equals 0. And we have x plus 3 equals 0. And we solve them all. So this, you can ignore the negative or you can work it out to show that when you divide by a negative, you still get 0. So our first answer is 0. Second answer, we add 4. X equals 4. And third answer, I subtract 3. X equals -3. I want you to notice, again, it was the same exact example as number 1, and notice the zeros. Here we had 0, 4, -3. Up here, 0, 4, -3. So we're going to start off the graph the same way. This is the last example. So here's our x and y axis. plot our three zeros. So we have a point at 0 on the x-axis, we have a point at 4 on the x-axis, and we have a point at -3 on the x-axis. Same as the graph above. If we look at the graph above, notice it started from the bottom and went up. Let's see what happens now when we have this negative in the front. So I'm going to put y equals, put in the original equation, plus x squared plus 12x. And some of you probably can already guess. This time, the graph comes from the top. So anytime you have a negative, it comes from the opposite side. So if it started from the bottom, you go to the top. So we're going to take our graph, and we're going to go down this way, and then up, and then down. So whenever we have a negative, it switches directions. If we had a negative in front of the x to the 4th, this would be an upside down w. So that's how we graph quadratic functions. All right, please make sure you put this in Canvas, a picture of it, so you can get credit for the notes.